What protein does for you? All the food you eat can be divided into one of three macronutrients: fats, carbohydrates, and protein. Protein is different from the others, because it is more likely to be burned as energy or used for other purposes, rather than being stored in the body. Fat is much easier to digest, while carbohydrates can vary depending upon type. Simple carbs digest quickly and easily, causing sugar spikes that lead to weight gain. Complex carbs take a bit longer to digest. Their digestive rate does not cause sugar spikes. Protein takes a while to digest, but it starts to burn energy the instant it finally enters the bloodstream. This macronutrient is important to every cell in the human body. While it is necessary for life, you can eat too much of it, just as with any nutrient. People need protein the most during the first 6 months of life, when according to body weight, an infant needs double the amount of protein an adult, or even an older child will need. What exactly does protein do? It would be impossible to list everything protein does here, but here are some of the things that make protein necessary. Building and repairing muscle, building connective tissue, adding material to the bone matrix, adjusting the pH balance of the blood, helping to form certain hormones and enzymes, like the ones that regulate sleep, digestion, and ovulation, strengthening the immune system. Antibodies are made from protein, creating new blood cells, forming RNA and DNA, making new neurotransmitters. How protein is digested. The building blocks of protein are called amino acids. Most of these amino acids can be manufactured by the body without any help, but there are 8 of these which the body cannot synthesize. These must be provided by food on a daily basis. These 8 are known as the essential amino acids. A protein that has all of the essential amino acids is a complete protein, while those that lack even one are incomplete proteins. Proteins that come from animal sources are complete proteins, while almost all plant-based proteins are incomplete. Amino acids, in turn, are simple compounds made from carbon, hydrogen, oxygen, or nitrogen. These amino acids link themselves into chains known as peptides, which can have more than 500 amino acids within them. The protein you eat is broken down into these basic amino acids when your body digests them. They can be used to create new amino acids and certain enzymes and hormones as your body absorbs them. Once protein enters the stomach, hydrochloric and gastric acid reduces it down to its basic components. There is an enzyme in the stomach known as pepsin, the only enzyme able to digest collagen, a protein in the connective tissue of animals, which digests the amino acids. These acids then move to the duodenum, the first section of the small intestine. More enzymes act here, breaking down amino acids into even smaller portions until they are small enough to pass through the lining of the intestines and directly into the bloodstream. Exercise reduces your body's production of protein. The protein that remains is converted into energy that enables your muscles to continue working. Once exercise is finished, the rate of protein production remains low for about 24 hours, while the burning of energy continues to be high. This is especially true for heavy resistance training. If no new protein is consumed during this period, the breakdown rate will be greater than the synthesis rate and the body will start taking fuel from the muscles. How proteins are evaluated. Proteins can be evaluated for their value, especially by endurance and strength athletes who rely upon protein for their performance. Such people usually judge protein on 2 scales. The first is the Protein Digestibility Corrected Amino Acid Score, or PDCAA, which evaluates a protein on its completeness, which a complete protein rated is a 1. The second evaluation score is the Biological Value, or BV, which is determined by how much of a particular protein is retained by the body once it is broken down into its basic components. Both of these scales base their standard upon the egg. An egg is a complete protein and 100% of it is retained by the body. It is unlikely that anyone but an elite athlete will care about the PDCAA or BV of any given protein. Luckily, there are simpler ways to determine how good a protein might be for you. First, your proteins should be low in fat, especially saturated fat. They should also be low calorie in relation to the size of the portion. They should also have other nutrients that are important to your day-to-day life. Taste is another priority. If it doesn't taste good, you're not going to want to eat it. Any protein supplements you use should be high in protein, of course, but pick the ones that are low in calories, without any added fats or sugars. You should look at the labels of any supplements you buy, especially protein bars. Many of them claim to be health bars but are not much different than the standard candy bar. Try ProfectR from Protica. A single serving provides you with 25 grams of protein and just 100 calories. How much protein is necessary? Everyone needs protein, no matter their age or circumstances. How much is needed varies with age, health, weight, and activity level. Protein is like any other nutrient in that it should not be taken in excess. Anything more than 35% of all calories per day is too much, even for athletes who need a high supply of protein. During the first 6 months, a baby needs about 2.2 grams of protein per kilogram of body weight, but they are the only ones who should ever consume that much. Even the most dedicated bodybuilder should have no more than 1.6 grams of protein per kilogram of body weight. For the average person, 0.8 grams per kilogram of body weight is enough. That's about 60 grams of protein per day for the average man, which is about 8 ounces of meat. Women can get by on less protein than men, unless they are pregnant, in which case they will need more protein. Too much protein for a non-pregnant woman can lead to a loss of calcium through the urine, which can in turn increase the risk of osteoporosis,